Can you not hear me?
I can hear you.
I can hear you now.
Oh, weird. There must be delay. I'm on at my father's place on Hornby Island, so there's going to be all kinds of horrible delay and terrible technology. So I will try to minimize the amount that I talk and maximize the amount that you guys talk. So and then just pretend like you heard the things that I said in real time and didn't see some kind of disjoint from when my mouth was moving from when the words were coming out. Hey, welcome to the Weekly Space Hangout, everyone. My name is Fraser Cain. I'm the publisher of Universe Today, and this week we've got stories about hidden windows, stories about updates on private spaceflight, NASA Inspector General criticizes asteroid search, the Rosetta landing site, new AMS results, the ultra-compact dwarf galaxy, and I don't know, no one put this on the docket, but we should probably talk about the fact that SpaceX and Boeing have been awarded contracts to take people to the International Space Station. So, and we've got Ramin Skibba, I hope I'm saying that right, is going to be joining us for his first ever Weekly Space Hangout, and we'll get him to introduce himself. So, joining us this week, we've got Dr. Brian Koberlein. Hey, Brian.
Hi.
And we've got, it's just on me, isn't it? Oh, I got Morgan Rehnberg. Hey, Morgan.
Hey, Fraser.
I don't know whether the camera's moving around or not. I hope it is. And Ramin, who we will introduce in a second when his internet settles. He's never come in and hang out with us before, so I don't know whether this is going to work. Okay, well, let's get cracking with the stories then. Anyway, so now have any of you been following this thing that I mentioned, the story that I discussed about the about SpaceX and?
Yeah, I intended that to be part of the private space flight.
Well, then why don't we talk about that, Morgan, and then you can bring that in as well.
Yeah, so there were two pretty big stories in private spaceflight this week, and the biggest one, of course, was that NASA basically finally picked winners out of the private spaceflight companies when it comes to getting humans into orbit and to the International Space Station. And they awarded a total of $6.8 billion worth of contracts to two companies. Boeing, who makes the CST-100 capsule, and of course SpaceX, who we all know as the PR-happy company that makes Dragon. And about 2/3 of that money went to Boeing, and about 1/3 of that money is going to SpaceX. And this came as a bit of a surprise, I think, to people, because a lot of the sort of pre-announcement rumors was that NASA was going to go solely with Boeing. Because Boeing was described as the safe option, and SpaceX was described as the exciting option. And NASA is the most risk institution on the face of the planet. And so being the safe option is pretty much a golden ticket to getting NASA money. And so in the end, they decided to kind of hedge their bets and go with both opportunities. And both of these companies have been guaranteed at least one manned spaceflight to the International Space Station with a NASA astronaut. And they each can get as many as 6 additional flights to the space station under this contract if everything goes well in the initial stage. The other big piece of space news that came out this week was an agreement between the United Launch Alliance, which is sort of a corporate partnership between Boeing and Lockheed Martin. They build the Atlas V rocket that NASA uses to launch pretty much all of their robotic missions, as well as the rocket that's used to launch most of the national security satellites for the United States. They announced an agreement with a company called Blue Origin, which you probably never heard of because they've never actually launched a rocket. They're best known for being founded by Amazon CEO Jeff Bezos, sort of as a competitor to SpaceX, but not quite as far along in the process. And what Blue Origin is going to do for the United Launch Alliance is build engines for the Atlas V. Because you might remember that the Atlas V is built here in the United States, but it has a major component, its main engine, that's built solely in Russia. And for a rocket that's used primarily to launch spy satellites and military communication satellites for the United States, as well as a variety of NASA missions, this is not a tolerable situation for the federal government. And they've been encouraging the ULA to look for alternative sources for these engines, and they're hoping in the next few years that they'll be able to source them from Blue Origin as opposed to buying them more or less off of the Russian government.
That's awesome. So I think Ramin's been able to make it. Ramin, can you hear us okay?
Yes, I can. Thank you. Can you hear me?
Right on. It worked. It worked. Sorry about the problems with the invite. We're having all kinds of problems with Hangouts this morning. So why don't you introduce yourself?
Sure. I'm an assistant project scientist at University of California, San Diego. I'm at the Center for Astrophysics and Space Sciences. I studied physics and astronomy, but my specialty is in in galaxy distributions, large-scale structure of the universe, dark matter cosmology, and things like that. But have a variety of interests. I've also got involved in citizen science and Galaxy Zoo, which is something which is pretty popular and a lot of interesting results there. So that's the basic introduction. Yeah.
Perfect. Well, welcome to the Weekly Space Hangout. We'll be gentle, I promise. So I know you put a story on the docket just about citizen science. So we'll sort of get to that in a little bit. But feel free if you have any knowledge, especially about some of the cosmology stuff that I know Brian's going to bring up. Feel free to jump in with some additional information. That would be great.
Okay.
So welcome and thanks a lot for taking some time out of your schedule to join us. So Morgan, we've been talking about this before, and I believe I predicted this just week after week after week that SpaceX was spotting an enormous opportunity to get itself prepared to be able to take away human space launch capabilities from the Soyuz, from the Russians. That this is an enormous opportunity that political discussions between the Americans and the Russians have been falling apart, and there's more and more emphasis on trying to make this homegrown, and without the space shuttle, there's no way to get people. So, and then boom, what do you know? SpaceX got the new Dragon 2 capsule. They've got a groovy new space, new chairs, a really great control panel. They're the shoe-in to be able to take humans up to the space station, and now the contract comes out, and I'm amazed they didn't just do it on their own, that they did do it with Boeing. I'm surprised.
Yeah, you have to remember that Boeing has an enormous history with various federal agencies, whether that's NASA or the U.S. Air Force or other branches of the government, and that experience counts enormously in these sorts of things. The government can count on Boeing to do the job it promises, basically, because they've done it over and over again over the last 30, 40, 50 years. And that guarantee doesn't exist from SpaceX simply because they haven't had the time to build up that legacy yet. And so this is really a great opportunity for SpaceX. It hasn't come out, the details of the contracts, as far as I'm aware, haven't been released yet. And so SpaceX would probably like us to think that they're getting less money because their capsule is cheaper and more efficient. Whether that is actually the case, we don't know yet. But either way, this is a great first step for them and for Boeing. And importantly, neither of these contracts are exclusive with NASA, which means that both these companies can offer rides to space with any private entity that they choose to do so. And that will enable more opportunities in space and therefore lower the costs of getting into orbit. And NASA knows this will reduce their costs as well. And so, with the exception of, North Korea or Iran or China, now these companies, once they sort of get that NASA stamp of approval, can then slap that on the side of their capsule and market this to anybody who wants to get to space but doesn't want to use the Soyuz. And so we're really much closer than we were just a couple of years ago to having a regular, reliable way of getting people and stuff to orbit.
The contract going to Blue Origins was a bit of a surprise, though. That, as you had mentioned, Blue Origins is founded by a fairly impressive company, but it's very stealth. And so nobody had really known this was coming together.
Yeah, right. Because they really
where are the successful rocket launches?
Right, and they haven't had rocket launches, but we don't know if they've had tests or not because those things very well can be kept private, and that's the way companies like Boeing and Lockheed Martin tend to operate. And SpaceX is really sort of the pioneer here in opening up this whole process from start to finish to the public, and certainly it's paid them enormous dividend in terms of public awareness and sort of the political capital that comes along with that. But that's by no means the only way to develop rockets and other space hardware. And so Blue Origin's very well could be much farther along than any of us really know, simply based on what they've shown to the ULA. And the ULA certainly wouldn't have contracted with Blue Origin if they didn't think they could get the job done, because that's the sort of thing that they could have built homegrown as well if they'd wanted to. And so one has to imagine there's more to that than we know at this point.
Yeah, they must have shown a very impressive test.
Yes, they must have.
Yeah. Okay, Brian, new AMS results. What is AMS?
Results. It's alpha magnetic spectroscopy. It is a particle detector that is on the space station. And it's looking at what we call cosmic rays. And cosmic rays are high-energy particles that were first detected in striking the atmosphere. And one of its main goals, or one of its espoused goals, is looking for evidence of dark matter. That's when it always hits the press all the time. And the reason is because one of the things that AMS can do that ground-based ones can't is they can actually do good particle counts in terms of what type of particles cosmic rays are. Most of them are protons, but you can also have electrons, you can have positrons, which are anti-electrons, and all this kind of thing. And one of the things within certain models of dark matter is that you could have an imbalance between the number of positrons that you detect and the number of the electrons that you detect. And about a year and a half ago, I think, there was this big announcement that they had detected hints of dark matter, and because they had found, the ratio of positrons to electrons were imbalanced in a way that could be described by dark matter. And this created a little bit of a scandal because they kind of claimed that it was detection of dark matter, and it wasn't. It was detection of particles, of which dark matter was one possible explanation among many. And so the new results, they've got more data. They're still showing an imbalance. It still could be due to dark matter, but it could also be due to a lot of other phenomena that are out there. So they don't have any strong evidence of dark matter yet.
I'll just add that, in my personal opinion, I think that it's probably unlikely that people will have the first strongest evidence of dark matter detection from space. I think it's probably more likely that people will use experiments on Earth. I would think, that are focused on dark matter.
I would agree. Yeah.
Experiments.
The problem with the space-based ones is that even if you have really good particle counts, there's multiple models that you can fit this to. And so being able to say this is dark matter instead of something else is nigh on impossible given the sensitivity of the devices.
Well, if the tests are conclusive, let's imagine, and the particles that were detected were in fact dark matter, then what model of dark matter is this confirming?
I actually didn't read up on that.
Oh,
I want to say it's possibly it's WIMPs or axions. I'm not sure.
Yeah.
Those are the most popular candidates, but I'm not familiar with this experiment, so I don't know.
Yeah.
Yeah, I mean the problem is they introduce some of the models, and some of the dark models have this imbalance, and some of them don't, and it's good. The problem is that it's kind of coupled with the idea that the whole purpose is to search for dark matter, and really it's a good experiment just on its own to get solid cosmic ray data counts that we haven't had, and that's just by itself is a good thing.
That alone is, these rays that are streaming from interstellar, intergalactic distances, right? And pelting the astronauts with radiation while they're up there.
Right, that's exactly it. And there are a lot of cosmological things. There's a lot of astrophysical phenomena that can create cosmic rays. And so having a good count allows us to eliminate certain models and open up other models based upon the observations we have.
Isn't this how we get the Fantastic Four? Somehow like this, with some kind of cosmic ray storm? A solar
One can
storm?
only hope.
Yeah.
We need...
That would be cool. Bring back the astronauts, and now there's... cool. So, all right. Well, let's try giving the newbie a shot here. So, Ramin, do you want to take a crack and give us some information about this citizen science project you were talking about?
Sure. Yeah, I'd be happy to. So citizen science, I guess, as a sign of how it's become popular, it's now joined the Oxford Dictionary as an actual term. So it's legitimate now. But it basically began with the Galaxy Zoo project back in, I think, 2008, and that involved so in the past, when you want to classify galaxies visually, you'd have, say, a poor grad student would try to look at the spiral arms and the shape of the central bulge of a galaxy and classify, say, 1,000 galaxies or something like that. But when we're trying to do a bunch of statistical studies, that's too small of a sample. Also, if you have one person classifying, they could be wrong in particular ways. So what people developed was this system where anyone could participate and online. And it was so popular that there was something like 1 million people participated, and 500,000 galaxies were classified, most of them a few dozen times, which allows for all sorts of statistical studies, including a couple that I've done myself. And then it spawned a bunch of other projects, and now Galaxy Zoo is sort of like the flagship of what's called the Zooniverse collaboration, and then there are other projects too, so involving say people looking at images of animals in the Serengeti, for example, or people looking at logs from old ships, trying to classify, trying to figure out what were old weather patterns and what does that tell us about climate change over a long period of time, for example. So there are just a huge variety of projects, and in fact a bunch of us involved in this collaboration are organizing we have a symposium planned for the American Association for the Advancement of Science meeting in February. In any case, so there was a paper last week which was sort of outlining some of the advances that we're making in citizen science and astronomy, and the lead author was Phil Marshall. He will actually be speaking in our session in February. He works on a project called Space Warps. So there's just a huge abundance of these projects. Many of them are very successful. Space Warps is trying to look at what people call looking at gravitational lensing, where if you look at, so gravitational lensing can be both what is called strong lensing and weak lensing, and it's where if you have an object in the distance and an object that's closer to us that's sufficiently massive, light will be distorted as it goes around the image, and so then this central this closer object will act as a lens. It can magnify an image or particular ways, and so then and we have so many of these images with the Sloan Digital Sky Survey that we need people to classify them, and so that's the basic idea of the Space Warps project. Mm-hmm. So I'm pretty sure that's one of the things that's discussed. I think both Space Warps and Galaxy Zoo is discussed in that paper. And the co-authors of the paper is Chris Lintott, who you may or may not be familiar with. He's the PI, the leader of the Galaxy Zoo project, and helped start it and get it make it popular.
Yeah.
So that's the basic idea for the concept.
Well, it wasn't one of the interesting stories that came out of Galaxy Zoo. I remember Chris was telling us that at one point, based on all the research, it turned out that galaxies were more likely to spin one way than the other way.
Yeah.
And that of course seemed ridiculous. And so then what they did was they then put all the images, they flipped them all, and they gave them to everybody again. And now all the galaxies tended to rotate more commonly in the other direction.
Yeah.
And
No.
what that did was it actually gave a preference, taught the researchers that human beings have a preference for being able to detect. They're more easily able to detect spin in one direction than they are in the other.
That's right. Yeah. People hadn't expected that. Some people were jumping to conclusions like, oh, maybe there's a preference in the universe, and then it turns out that we just have a preference when we classify things. And so that's also why psychologists are also interested in how these classification systems work. But yeah, so that was the outcome of that analysis, which is that there actually isn't any preferred direction of the galaxies.
That would have been a pretty significant discovery.
Yeah.
Awesome. Okay, so Morgan, let's talk about Rosetta.
Yeah, so seems like we've been talking about Rosetta pretty much every week for the last
month everybody, get used to it. We're going to talk about Rosetta.
We'll be talking about it every week for the next
weeks.
2 to 3 months. So this week's news is long awaited. They finally selected the landing spot for the Philae rover, lander, which is expected to touch down on November 11th, and they've picked what they termed Spot J. And landing site J is on the head of Rosetta, or of the asteroid 67P Churi-Guri, as we've all been instructed to call it. And if you remember, this comet looks kind of like a duck. And this is kind of right on the crown of the head of the duck. And they picked this spot mainly because it seemed like the safest. Or as I saw in one place described, it was and they're really kind of tamping down on expectations for the landing. If you look back in their original proposal 10 years ago, or 15 years ago now, they estimated that if this comet was a perfect sphere, that they'd have a 70 to 75% chance of landing on it successfully.
So they think the chances are pretty low then of this working out?
They're not saying pretty low, but they're certainly cautioning against assuming this is going to go off as well as many of our other landings have recently.
Mm-hmm. It does sound like there are a lot of boulders down there, and uncertainty of exactly where it will.
Yeah, there's really two problems at work here. One problem is that it doesn't really have a powered descent to the surface. It's just going to kind of drift down there and latch on wherever it hits. And that means that they can't really predict very well where it's going to land, maybe within a kilometer or so, a few hundred meters or so. The other problem is that they are using images that, while of good resolution, are not of boulder-sized resolution. And this is a problem every time we try to land in somewhere in space. We're usually pretty lucky if we get like 10 or 20 meters per pixel resolution. And that sounds really good, but until you realize that a house is about 10 meter, 20 meters sized. And so anything smaller than a house is basically invisible in these pictures. And so they have to do all sorts of tricks by looking at images from different sun angles and things like this to try to reconstruct an estimate of how smooth the surface is below the level that they can see, which is far larger than this tiny little lander. And so they've picked this area because they think the slopes are less than 30 degrees, the cliffs are somewhat minimal but not entirely absent, and this has the least amount of boulders of any of the landing areas that they looked at. And so you might get the picture here. This is not a glowing endorsement of this particular landing site. They also had to make sure that it wasn't going to take too long to land. It's going to take about 8 hours to drift from Rosetta down to the surface. And this is important because it's battery powered. So as soon as it detaches from Rosetta, it loses that feed to the Rosetta solar panels, and it operates on batteries alone. And if the drift was going to take too long to get down there, then they'd use up most of their battery life before even landing on the surface. They also selected a backup landing spot, which is Spot C, and it was basically the second least worst of all the bad options. And they picked this one mainly because it was well illuminated by the sun. which will make for good imaging, both from Rosetta of the lander and of the lander, or from the lander itself on the surface. And that wasn't the case with a lot of their other selected possible landing spots. And so now basically they go into high gear because today is September 19th. They're planning to land November 11th. Because this thing is battery powered, it's only going to last for a short amount of time. They have to program every action that it's going to do from the second it detaches from Rosetta to the moment its battery dies. And they have to have enough stuff programmed in there so that if the battery lasts longer than expected, they keep doing stuff. This happened with Huygens when it landed on Titan when dropped by Cassini. They expected it could only last 2 hours. Ended up lasting many hours longer than that. And thankfully, they had programmed in contingency observations to do continuing on. And normally, these kind of plans take years to put together. And they've been working on the time-sensitive observing plan for New Horizons now for a long time, and it's still a year out to go. Here they have basically 6 weeks to figure out exactly what they can do and what they can't do at this location, what order they want to do it in, basically prioritize. We have to do this. We can wait and see if we have time to do these things.
Do you know why? Do you know why they picked November 11th? I mean, does Rosetta have to get in a particular position or orientation?
It's not a hard a limit. So if they have to slip beyond November 11th, I don't believe that's a problem. Basically, they don't want to wait too long because every day you wait is a chance for something wrong to happen. And so
that's just life, isn't it?
Right. There may also be some considerations in terms of the illumination angles from the sun, but I'm not familiar exactly with their constraints.
But isn't there also like activity levels? Like they're wanting to wait. Yeah. They want to get the lander down there before the comet really.
Right. If it gets too close to the sun's heat will warm the comet up. You can imagine, snow on your ground sublimating off, and that would fog up the cameras. It could damage the lander. It's going to do all sorts of unpleasant things. And they'd rather observe those kinds of effects with Rosetta, which will be safely, far away from the comet itself. And they can use Rosetta's much more powerful cameras and instruments to observe that process. With the lander, they want to get in there, basically sample the ground. What is it made of? What does the surface look like on the small scale? And then Rosetta will answer as many of the other questions as it can.
Yeah. I guess to answer what I was going to ask, which was, like, once they do get down on the ground, they've got a very tight window of time. Like, is it a day, days, you think, till the battery runs out?
It's less than days, I believe.
Yeah.
I don't remember the exact... Yeah, it's
hours.
Hours is what I would say.
So you don't have a lot of time to do any deep questions.
No. And the first thing they have to do is they land, and they immediately have to take a 360-degree panorama, because the most important piece of information for understanding anything that they do after that is the orientation of the lander. If the lander lands more or less on its side, then that's going to drastically change what they can do and how they interpret the results they get back. Mm-hmm. And certainly the panorama is going to be a prime piece of public relations media, which is vital for this sort of thing as well.
That has to be stressful for the scientists. Years and years of work coming down to just a few moments, basically.
Oh, absolutely. I mean, this thing has been in flight now for more than 10 years. It's probably been in development for between 15 and 20 years, and it's all going to come down to a few hours on November 11th to see whether or not all this work comes together or not. But it's important to remember if the lander fails, the mission isn't over. Rosetta is still there. It's in good shape. Most of the instruments are on Rosetta, and they plan to use Rosetta for at least the next year to study this comet as it makes this approach to the sun, and they can see how the life cycle of the comet changes over the course of a comet's year.
Well, maybe they'll land Rosetta on the comet afterwards, just like they never intended to land on Eros with Near. So, okay, cool. All right, so Brian, you've got one more story for us.
Sure.
About a dwarf galaxy.
And an ultra compact dwarf galaxy. So it's called Sorry, it's called M60 UCD1, which is Ultra Compact Dwarf 1. It is a satellite galaxy of M60, and it is, as far as we know, the most dense dwarf galaxy we've seen. It has about 140 million stars, and it is compacted into an area about 300 light years wide. So the analogy that you could use is, in our night sky you see about 4,000 stars with the naked eye. And if we had a planet that you could stand on in this dwarf galaxy, you'd see about 1 million stars in the night sky.
Wow.
So
pretty cool.
it's extremely dense. It has, in its core, it has a supermassive black hole that is about 15% of the mass of the dwarf. Compare that to the Milky Way, where it's 0.01% of the mass of our galaxy, supermassive black hole in our galaxy. So this is basically black hole and a few stars. And all the stars are very compact. And we're not entirely sure how it formed, but it seems like, given its position with M60, that it likely has been cycling through the center of M60, and as it does, it gets stripped of these outer stars. So if you consider you have a galaxy that probably had billions of stars to begin with, and then makes kind of a close approach to the supermassive black hole in M60, and that strips off the outer stars and kind of scatters them through M60. And then every time it swirls around, it's getting more and more stripped until basically you have the 1%ers that are still there.
So some people think that's what's happening with the large and small Magellanic Clouds, which are two nearby galaxies to us. But what I was wondering is, do they, with this compact dwarf galaxy, do they have evidence of stripping? Do you have like a tidal tail or anything like that that's visible?
They've done some simulations, or maybe some hints of tidal tails. Then they've done simulations in which it matches the observations there. That seems to be the strongest one, but I don't think they have enough to confirm that that's actually what it is.
And so if this
cool
is
that it has
the
a
case
black
that you're
hole.
talking about, though, you're going to get the situation where the supermassive black hole is going to keep orbiting, and eventually they'll merge?
Eventually they'll merge, yeah. That's the idea.
And so this could be the far, far future of what happens with Andromeda and the Milky Way.
Yes. Although
That
they're more
we would
similar
eventually
sizes.
become a ultra-compact dwarf galaxy.
Yeah.
Is that a
small.
possible explanation for lots of the dwarf galaxies we see out there, or only these ultra-compact ones?
Only the ultra-compact ones. I mean, dwarf galaxies can form on their own, and they don't necessarily have massive black holes that are the majority of their mass. It's these ultra-compact ones with comparable to their mass, large supermassive black holes, and that's the thing that's distinctive.
Some people,
you can have a compact dwarf. Go ahead.
Some people think that there's that there's sort of like a mass limit, like galaxies above some mass may have a supermassive black hole in the center of them, and the question is why, and what determines that mass scale. How do these kinds of galaxies form? And
right.
I guess it sounds like that's not really known yet.
No, it's not. We find some relationships, but we're not there yet.
All right, so we got one last story, Morgan. You want to talk about criticisms of asteroid searching?
Yeah, that's right. So about 10 years ago, the U.S. Congress charged NASA with the goal of finding 90% of the asteroids that are potentially hazardous to the Earth and over a size of about 140 meters. And just for comparison, that's maybe 10 times the size of the asteroid that hit Chelyabinsk last year. So these are asteroids that, if they struck the Earth, could cause region to continent-wide damage, and we want to find them. And so NASA has a program of using a variety of telescopes, both in space and on the ground, to look for these asteroids. And their own Inspector General came out with a report this week saying they were not on track to complete that 90% goal by the year 2020, which is when they were supposed to have by. And he said they didn't have enough people working on the job, they didn't have enough money committed to the task, and they didn't have solid milestones along the way to reach. And this is after NASA has already increased the budget over the last 5 years for this program by a factor of 10, up to today when it's $40 million a year are being spent on this program to find and track these asteroids. And NASA kind of sort of tacitly acknowledges that they're not on track to do this and says that they'll work harder and find a way to make this program work more efficiently.
So are there? So I know that Pan-STARRS is one telescope they wanted to use. Are there? So what are the other ones that like you mentioned ones in space too? I mean, are there ones that are dedicated to looking for asteroids, or ones that like dedicate a certain amount of time or resources?
So there's
WISE
no
has been one.
there's no space-based telescope that's dedicated to it, but the WISE telescope, since being reactivated a couple of years ago, has found hundreds of thousands of asteroids and is maybe surpassed all the other surveys now in terms of sheer number of asteroids detected. We also use the Catalina Sky Survey on Mount Lemmon in Arizona is fairly heavily dedicated. Pan-STARRS. There's debate on whether the next generation large synoptic sky survey telescope will be able to find these guys or not, just because it's kind of in this awkward area between taking pictures fast enough versus not fast enough to find these guys in there. And then once these big surveys find them, it kind of trickles down to smaller telescopes, kind of 1 to 3 meter sized telescopes, because you have to go back a week or a month later and find it a second time. And if you don't find it a second time, you basically lose it because the uncertainties in the orbits are too large. And then once we've found it a couple of times, NASA publishes it to a web page, and they encourage amateur astronomers to go out and look for them themselves, because every data point we have strengthens our understanding of the orbit, the trajectory of the asteroid.
Now, there's a couple of space-based, asteroid hunting missions that have been developed, and they're theoretically in the works. There's the Sentinel mission that I know the B612 Foundation wants to get going, and there's a bunch of these. So do you think that maybe this is going to speed up the launch and deployment? I mean, even if these get pushed up in the next couple of years, they're not going to meet the targets by 2020.
No, the 2020 deadline is going to pass, basically, without...
It's basically passed in space terms.
Yeah, without having this problem solved. Anything that we can launch will help. And any amount of resources we can dedicate to this will help. It's a tricky line for NASA to walk because there's not a lot of science value in finding these asteroids. There is some science value, but there's not a lot in comparison to the value you could get from tasking these telescopes to look at other objects, whether they're in our solar system or outside of it. And so they face pressure from the scientific community to sort of only do the bare minimum for what's necessary for this. The policy community says, well, this is a strategic goal that we have to have. And that's sort of, I think, where this lack of direction is coming from, that the Inspector General was highlighting, is finding the right path to walk through that.
Yeah.
So
it's kind of like buildings. I was going to say, it's kind of like buildings on a campus. Everybody wants their name on the new shiny building. No one wants their name on the refurbished one.
Yeah. So we should point out, of course, that we're not in any sort of imminent danger here. NASA categorizes these the threat posed by these asteroids from 0 to 10, where 0 is it's either too small to make it through the atmosphere, those become shooting stars, or it has virtually no chance of striking us in, say, the next 1,000 years or something, to a 10, which is, this asteroid is certain to hit us and it will cause global devastation. And currently, I checked this morning, in their database, there's not a single asteroid that's rated anything other than 0.
Yeah.
And it's not unusual for us to find a few 1s every year, but then as we go through this process of observing them multiple times, getting a better idea of their trajectory, every time they go from a 1 to a 0. And we've never found something that even rated up to a 2.
Also, space is pretty big and the Earth is pretty small, so it's,
Yes, it is.
Unlikely that any given asteroid will pose a threat.
Well, I know there's a lot of astronomers, space astronomers. Mike Brown's a good example. He sees no urgency in searching for asteroids at all. He doesn't care. He doesn't think it's a risk.
Well, an argument that people will frequently make is that even if we find one of these guys, there's really nothing at this point we can do to stop it. None of the asteroids that we find today, even the ones we do successfully find, do we see more than weeks to months before they would strike the Earth. And there's nothing we could do in weeks to months in order to deflect the asteroid or anything like that. And we don't ever have really the precision to understand where that asteroid would hit on the Earth. And so if we're talking about an asteroid that could, cause country to continent-sized damage, we can't just start evacuating parts of the Earth because we think an asteroid might hit it. And so if we don't really have the ability to do anything about it, it doesn't make sense to dedicate the resources to finding them. And that's an argument that a lot of scientists and other people will make against these sorts of searches.
But it is one way to try to get money funding from Congress is to say that your telescope will do something towards finding killer asteroids. Yeah. So it's something that obviously Congress members are interested in.
I mean, the counter to that is that I think if you run the statistics correctly, you're more likely to die in an asteroid collision than a lightning strike. Because if a big one comes and takes out pretty much everyone, you're going to be part of that. And lightning strikes are extraordinarily rare.
Right. Well, maybe we should somehow figure out a way that the Weekly Space Hangout can contribute to finding asteroids and see if we can get some funding from Congress. If only I wasn't a Canadian. All right. So all right. So let's see if we got some questions from some of the viewers. Apparently, there's some kind of clappy thing at the bottom of the screen that people don't like. We don't see it. We have no idea what you're talking about. The applause app.
Oh, Nicole keeps talking about this, and I don't know what it does.
Nancy Graziano says that the clappy thing can be turned off. Nicole did it for Learning Space. I haven't even turned it on. So, Muffy1801 says that November 11th is when 67P is predicted to be 3 AU from the sun. So,
okay, that would be the transition. Yeah. Between active and inactive.
So Elad Avron asks, is dark matter all around us, and we just can't detect it, we just can't interact with it, or is it some distant area of the universe and we're just detecting it from far away? So Brian, is dark matter all around us, we just don't detect it, or it's just far away and we can't reach it?
We don't know.
Good question.
It's more of the first one.
Yeah, I think it's more the first based on the theory.
It's basically assumed or thought to be everywhere, but it does take on certain structures. So there's some parts of the universe where there are underdense regions, kind of sometimes even voids, while in other areas we have sort of filamentary structures, and then in the densest regions you have what people call dark matter halos. And people think that once a clump of dark matter is big enough, gas cools and forms a galaxy within it in that location. So basically, almost every galaxy is in a dark matter halo. Mm-hmm. The only exceptions are ones where we talked about stripping before. Dark matter tends to be less dense than galaxies, and so you can have stripping of dark matter and then later the stripping of stars. Right. So some people call those quote unquote orphaned galaxies because the dark matter has been taken away. Mm-hmm. But the Milky Way has a dark matter halo. So as far as we're concerned, we're surrounded by dark matter particles, but we just don't interact with them.
Right.
Roshan Bukhari says, if a big exotic asteroid hits a poor country, wouldn't that country get rich with all the exotic metals brought by the asteroid? That's not a good way to mine minerals.
If they could somehow
moves in afterwards,
once everything was no longer on fire. Yeah, once everything was no longer on fire, and then the neighbors could move in because everybody would be killed, and they might find some exotic metals.
when we talk about asteroids, they're very difficult to describe because they're dark, they're strangely shaped, etc. So we often describe them in the anticipated impact energy that they would have if they struck the Earth. And these are always measured in megatons of TNT. So we're talking about the equivalent of the largest or larger nuclear weapons that we've ever had here on the Earth. An asteroid of this size would be a very bad day for all of us on Earth, and a very, very bad day if it happened to hit your house.
But the what is it in Sudbury, Canada? There's the nickel mine, and that is an ancient asteroid strike.
Yep.
So a lot of places on Earth where there is just mines of pure nickel, pure iron, that's because an asteroid hit. So in theory, yeah, if you're willing to destroy your entire country, you might choose to hit it with an asteroid, and then you could mine it later on. That sounds like a super genius, evil genius scheme. You know, someone with a cat, you'd be like, I'm going to mine the plutonium from space. So,
I prefer
all right,
to go out and get it myself.
Yeah, just buy it at the store. Michael Jobin says, are there black holes at the center of globular clusters? We don't know yet, right?
I think people usually say no. I think there's a distinction between globular clusters and dwarf galaxies.
There's been some discussion about intermediate black holes, not the supermassive and not the stellar mass, but in between, and some of those may be in globular clusters. But we don't have I think there's one in which we've got pretty good evidence to support it, but most of them we don't. The problem is that most globular clusters are so dense, it's hard to distinguish, an intermediate mass black hole from just a dense concentration of stars.
Yeah.
So Guido Bieber's got an interesting note that there was probably a lot of bad press because of Boeing and their battery problems with the Dreamliner jets in the future, and to see if that might have some impact on the on them winning the contract to get humans up to the space station.
Yeah, I don't know how connected the various components of Boeing are. They weren't all even originally the same company, and have kind of been merged into this conglomerate that Boeing operates. But they have, a civilian space aircraft division. They have a military aerospace division, and then they have a space division. And how connected those are, I don't know. But it certainly wasn't good news for them.
I think one of the things is it's kind of a warning shot to Boeing, in that you're the safe choice, but you ain't the only choice.
Yeah. No one ever got fired buying IBM, right?
Until they did.
Yeah, until they did. Cool. Why don't we wrap things up? So I just want to give people a chance to find out more. So we'll let the newbie go first. So Ramin, where do we find out more about you? Where can people find out more of your writing or your projects?
Okay. Well, I blog at raminskibba.net, and there's also a link there to my work website, which is at cass.ucsd.edu. And there I have all my stuff, work on dark matter and galaxies. My blog is a lot about science and politics, although sometimes I do put things on there about citizen science. And
are you on the Twitters?
Yes, so it's at Ramin Skibba is where I am on Twitter.
Great. Yeah, and then next week we'll teach you how to make one of these things.
Okay, thanks.
Great. All right, Dr. Koberlein, where do we find out more?
You can find me on Twitter at Brian Koberlein, and you can find me on my blog. It's briankoberlein.com.
Sweet. And just once I just want to remind you, Brian Koberlein is writing every day like crazy and posting on Google+. He's got great stories. You should definitely check out his website. Although you've given it a name now, right? One Universe?
One Universe at a time.
One Universe at a time. And you also have, man, you need to get better at self-promoting, Brian, so allow me to help you with this.
Okay.
You've also got a Patreon campaign so that people
I do.
can contribute to your Patreon campaign. So they go to patreon.com/Brian Koberlein.
Brian Koberlein. Yeah.
Perfect. And you can contribute to Brian's Patreon campaign, which I have.
Yes,
so
thank you.
You should do the same. This will allow him to not have to be a professor anymore.
I don't know about that.
I don't know about that. All right.
Allow me to finish
All
a
right.
book.
Okay. Oh, that'd be cool. If we fund it, will you promise to write a book?
Yes, that's
Okay.
part of the goal.
You heard it here, folks.
Deal.
I've got it blocked out. I just have to go through and write the
Go to
details.
patreon.com/Brian Koberlein and help fund him writing a book. All right, Morgan Rehnberg, where do we find out more?
Yeah, I wish I had Brian's writing stamina. Well, you can find me as always over at the Google Plus Space Community right after this, taking your questions and then throwing the rest of them to Brian when they seem too hard to answer. You can find me on Twitter at Morgan Rehnberg, and you can find me at my blog, cosmicchatter.org.
Fantastic. And do you have a book coming out?
Like Brian, I have plenty of outlines.
Yeah. You have a Patreon campaign yet?
I do not have a Patreon.
Oh, well, there's your problem.
There you go.
Great. Okay, so once again, I'm Fraser Cain. I'm the publisher of Universe Today, and I don't know if you have all heard that I have a new job. I work for, I'm now the product manager for a company called HeroX, which is a spin-off of the X Prize Foundation. So the X Prize Foundation puts out a couple of big prizes every year or every decade, and our goal is to let anyone make an X Prize. So check it out, herox.com, and come up with an idea for a challenge, and then talk to me, and we'll try and see if we can get it crowdfunded. So, and also you can of course go to universetoday.com, and I'm fcain on Twitter, and we will see you all next week. Thanks, everyone.
Thanks. Bye.
Bye.